So just kind of for spacing purposes, you can look real quick. I'm going to put 2 slides of formulas up here, and all these are going to go in the basic identities tab. So the first ones, the quotient and reciprocal identities, we've talked about these. We know tangent and cotangent are reciprocal, sine and cosine, sorry, sine and cosecant, secant and cosine. We know that already. We've also talked about how tangent is sine over cosine and cotangent is cosine over sine. So these are not on the formula sheet I will provide you. You want to go ahead and write them down in your flip book because they are choices that we have when we're working with these identities. Last ones we're writing down today, again, still on that basic identities tab. The Pythagorean identities, we did these back in the very first chapter. Those 3 are on your formula sheet, so those are given. The negative angle identities are not, but we've talked about this before. When have we looked at these? Yeah, when we were graphing, we talked about if things were even and odd. Remember, cosine and secant were the only even functions, which meant that if you had a negative on the angle, you could just drop it. The others were all odd, so with all the others, the negative comes out in front. So that's just, the negative angle is the same as even and odd, which we did in chapter 4. These identities are true whether your angle is in degrees or radians, so that doesn't matter. We're just going to be taking trig identities and manipulating them today to turn them into something else. Okay, so let's take a look at this problem. Actually, I'm going to do a different one first, if that's okay. Let's start with this one. I want to simplify cosecant x minus cosine x cotangent x. So simplifying a trig function is saying we are going to take it and we're going to turn it into something equivalent. Okay, so I'm not necessarily changing the problem, but I'm finding an equivalent way of writing the problem. A good starting point, especially if you don't know where else to go, is to write everything in terms of sine and cosine. So when I see cosecant x, what is cosecant x equivalent to? It's the reciprocal sign, so that is 1 over sine x. Okay, minus cosine x, that's already in terms of sine and cosine, so I don't have to do anything to it. Times cotangent. What is cotangent? 1 over tangent, or cosine, oh, did you write it down, huh? Or cosine x over sine x. So they're both options. Let's go to sines and cosines. Since I'm changing everything else, sines and cosines, let's do this as well. So cotangent is cosine over sine. Now I'm just going to try to simplify this. So 1 over sine x, there's really nothing I can do. This is just like a cosine x over 1. When you multiply these things, you just multiply the top, so cosine times cosine is cosine squared. Multiply the bottoms, 1 times sine is sine. My fractions have the same denominator, so what does that mean? Yeah, we can go ahead and subtract them. We can put it together. We can make one big fraction. So basically we're doing anything, any algebraic rule, you know, to add or subtract fractions, we need common denominator. That's still true with these trig functions. All right. Any ideas how else we could simplify this? Do I know what 1 minus cosine squared would be equivalent to? Look at your identities. Okay. So we have this identity right here. Sine squared plus cosine squared equals 1. That is probably going to be our most common identity. If you subtract over the cosine squared, that means sine squared is 1 minus cosine squared. That's an equivalent way of writing that identity. So in my problem, I have a 1 minus cosine squared, so I can replace that with sine squared. Did I lose anybody right there? All right. What would sine squared divided by sine be? Sine. You can just cancel one of those signs. So this turns into a sine x. So essentially what we just found is this original identity is the same as sine x. Okay, if I plugged in like 30 degrees, we know the sine of 30 degrees is 1/2. If I plugged 30 degrees into the original, I would have also gotten 1/2. These are just two equivalent functions, or two equivalent expressions. Questions right there? These take some getting used to, so don't panic if you don't know where to go yet, but I just want you asking questions if you don't understand how I did something. The other thing I really want to stress on these problems, we are leading into the idea of proofs. So your work is your answer. I'm not just looking for the sine x at the end. I'm wanting all the steps for how you get there. So this is the one place, normally I'm pretty lenient on the amount of work you show me, but this, we are proving things, so the work is your answer. You have to be writing down all these equivalent steps. Okay, the other thing, a lot of times there's more than one path to get there. So we could start out on this problem doing sines and cosines like we did on the last one. There's another option as well. Does anybody recognize anything here? Yeah. And a third option would be to do each thing over cotangent squared. So that is actually an option.
1 plus cotangent squared x is the same as cosecant squared.
Yeah. And the third option, the top is 1 plus cotangent squared, which we have as an identity, cosecant squared. So really, we've already talked about 3 different places we could start on this problem. And they're all correct. They will all get us to the final answer. So it's just picking somewhere, and it's wherever your mind goes. You know, do you think I don't have a clue what to do? If so, go to sines and cosines. Do you recognize that that's an identity? If so, plug that in. Okay, third option, split this thing up. So which path do you want me to take? Okay, so 1 plus cotangent squared, we wrote down from our formulas, is cosecant squared. All right, do we have an identity that tells us what cosecant squared divided by cotangent squared is? Probably not. So if you get stuck, anytime you're stuck, changed everything to sines and cosines if you don't know what to do. So what is cosecant? And so since cosecant is 1 over sine, cosecant squared would be 1 over sine squared x. Cotangent is cosine over sine, so cotangent squared would just be cosine squared x over sine squared x. All right, so we have a fraction and a fraction here, which is pretty ugly. And we have a couple options. We can flip and multiply to get rid of it. Another option, what's the denominator for both of these? In a fraction, as long as you multiply both the top and the bottom by the same thing, that's a legal move. So if I wanted to cancel the denominators, I could just multiply the top and the bottom of this fraction both by sine squared x. So then these sine squareds cancel. So on the top, I'm just left with 1. On the bottom, the sine squareds cancel, so that gives me cosine squared. What is 1 over cosine? Secant, it's a reciprocal cosine. So 1 over cosine squared x would just be secant squared x. Questions? Please ask. When something pops in your head, please ask about it. We're just going to keep trying these. So let's say I asked you to simplify. Okay. Any ideas on what we could do here?
Change SEC and CSE to the reciprocals.
Yes. Secant is 1 over cosine. You have to make sure you're writing your, I don't always say my theta or x because I'm bad about that, but please write it. Don't just put 1 over cosine, put 1 over cosine theta. You have to have that angle. Cosecant theta, so 1 over sine theta, times cosine theta minus sine theta. So if you don't see anything else obvious, go to sines and cosines. Now think back to algebra. If you have 2 parentheses like this, what do we have to do? What? Okay. What is 1 over cosine times cosine? This is like cosine over 1. So if you multiply the tops, you get cosine. Multiply the bottoms, you get cosine. So cosine divided by cosine is 1. This is like sine over 1. So minus, so if I multiply those, 1 times sine theta is sine theta on top. Cosine theta times 1 is cosine theta on the bottom. Inside. So 1 times cosine theta is cosine theta. Sine theta times 1. Minus. This will give me sine theta over sine theta. What happens to my 1s? Those cancel. Positive 1 and negative 1 cancel. So I have a negative. What is sine theta over cosine theta? So sine over cosine is tangent theta plus cosine over sine is cotangent theta. You could also write this as cotangent minus tangent, cotangent theta minus tangent theta, and that's equivalent. Okay. Questions on that one? We're going to do just a couple more together, and then I'll give you guys some to try so you have time in class to ask questions if you get stuck. I want to make sure you understand when I say like cosine squared negative theta, what that means is you have the cosine of negative theta and then I square that. Tangent squared negative theta means you're going to do tangent of negative theta and then square that. So you don't really have to write that step, but I just want you to clarify what that means. What is cosine of negative theta? Cosine theta. So I'm just going to write that as cosine squared theta. All right, on the bottom, what is tangent of negative theta? Negative tangent theta. But I square that. What happens if you square a negative? It turns positive. So this would just turn into tangent squared theta. Okay, everybody take a look at that and make sure you understand how I got to that point. Can you answer that? Sure. So I use the negative angle identities. So with cosine, we said cosine of negative theta is just a regular cosine theta. So that was where I got my cosine squared. On the tangent, it said the negative pulled out in front. But if you pull that negative out, this whole thing is still squared. So because the negative was squared, it became just positive.
So why is the squared still there if we already used it?
We squared the negative, but we haven't squared the tangent itself.
Okay.
All right. What is 1 minus cosine squared? Sine squared. That is going to be the most common identity. It will come up all the time. So 1 minus cosine squared theta is just sine squared theta. What is 1 plus tangent squared theta? Secant squared theta. Okay. We're close, but we could probably still clean this up a little bit. What could we do?
Change secant.
Yeah, what could I change secant to? Okay. So because it's secant squared, that's 1 over cosine squared. So we can use the same trick that I did on that other problem. If we multiply the top and the bottom by the same thing, it's legal. So we could just multiply by cosine squared on top and bottom. So on the top, we have sine squared theta, cosine squared theta. On the bottom, what's 1 over cosine squared times cosine squared? 1. Those just cancel. So we could put over 1, but we don't have to. Because these are multiplied, sine squared plus cosine squared equals 1, but we don't have any identity for when they're multiplied. So that is our final answer. And I know part of the hardest part of this sometimes for people is understanding when to stop. And that will get better, like tomorrow. Okay, so just bear with me for a day or two, and we'll get to the point where we understand that a little bit better. When we start giving proofs, you'll know what your final answer has to be, so you'll know when to stop. A lot of times here, we always go to sines and cosines, and we just simplify until there's no more identities we can use. All right. We do one more? All right. Let's do sine x plus cosine x squared minus the quantity sine x minus cosine x squared. What does it mean when I say we have that parenthesis squared? And to square that means we have the same thing twice. So what do we have to do? What? Okay, so I'm going to start with that first piece then. If I FOIL these, we get sine x times sine x, which would be sine squared x, plus sine x cosine x, and plus sine x cosine x would be plus 2 sine x cosine x. And cosine times cosine is cosine squared x. We have to do the same thing with the second. So we have to FOIL those. So sine x times sine x is sine squared x minus sine x cosine x and minus sine x cosine x. So they're like terms, so you just do minus 1 plus minus 1, so negative 2 sine x cosine x. And then negative cosine times negative cosine is positive cosine. Bless you. What would you do here? Right. Since this is a minus, I'm going to distribute a negative through the second one. And then when we combine like terms, sine squared x and negative sine squared x cancels. 2 sine x cosine x plus 2 sine x cosine x would be 4 sine x cosine x. Cosine squared x minus cosine squared x cancel. So that's our answer, 4 sine x cosine x.